In this tutorial we'll take a look at how to recreate For Honor's lock-on mechanic, which basically lets you focus on a single enemy at a time and change between multiple enemies to focus on by retoggling. On the screen you can currently see the comparison between my final result and the way it looks in For Honor. I personally believe I got a really similar result. Before starting, if you want to see more videos in the future like, consider subscribing to stay up to date with everything. Big shout out to Xeon, Donald Anderson, Kamasutra Industries, Andrew Millspog, Nino, Daniel Moore, Badr Al-Kahtani, and Roduk for the awesome support this month. I really appreciate it. And now, without further ado, let's jump straight into the tutorial. The first thing that we are going to do is to create a decal and a material for that. I already have my image right here. It is a circle that slowly fades in, right? And the reason that we are going to create this material for the decal is to make sure that the player has a way to know which of these three enemies has selected on its screen. So let's go create a material. I'm going to call this decal _m. Let's get into it and let's go in the main material node. Here at the material domain we are going to go and get deferred decal, and then at the blend mode we are going to get translucent. Now let's get the image in the material editor, plug the first node in base color. So this way we are going to get the white stuff on, we can't actually see it here because it's a decal, but actually it works. Right, so we are going to get the white stuff in here, but because we also have some things that we don't want to be able to see, like this black stuff, we are going to plug the last pin in opacity. So that is going to get rid of everything, and if we are going to get a decal in the world, and select the material to be the one that we just created and save this material, we should be able to see the end result. You can even see it in here, you see the circle, but because of the perspective it looks a little bit distorted. You can clearly see this now here. Okay, let's delete it. And we will need to go in our characters, open the blueprint editor. And by the way, all of these 4 blueprints here are the same. They are the third person character and they are the default template. Okay, let's go in the viewport, add a decal. I'm going to attach this to the mesh and I'm going to rotate this 90 degrees. Okay, I'm going to select my material and click on this arrow. Okay, I'm also going to scale this down because right now it's way too big. So I'm going to disable the snappings. Okay, also on the X and on the Y and on the Z axis, I'm going to put 0.2 and 0.2. That should be good. And now I'm also going to put this at this fit. Okay, this should work. Let's go and see if it's visible. So you can see it is visible. It's right here. Maybe we can make it a little bit bigger. Compile and let's see one more time. Alright, this should be fine. We should be able to see it very well while we are going to lock on the enemy. Alright, and now we can go and probably start creating the blueprint. Let's think a little bit about the mechanic before creating anything in the event graph. What we want to do first is to detect all the enemies that are going to be around the player, right? So we know which enemies we can lock on. For that, we're going to add a new sphere collision. Okay, this is going to go, we are going to attach it to the mesh. And now we also need to go the collision presets, go to custom, and we need to ignore the visibility, the camera, world static, world dynamic, vehicle, and destructible. The only thing that we want to overlap with are the pawn and the physics body, because otherwise the spheres can collide with each other and create overlap events, but we only want to be able to lock on the enemy once the sphere collides with the mesh, with the physics body. Alright, now let's scale this. So the sphere radius can go up to 700. Of course you can play around with this value, it doesn't need to be 700, it is here. You can put it 800, 900, even lower, 600 and 500, whatever suits you. Okay, let's go to onComponent begin overlap, and let's also get onComponent end overlap and see how we need to code this. First of all, let's create a new variable, and I'm going to call this enemy array. We are creating this so we are going to have references to all the enemies that are inside the sphere. Okay, the type is going to be a third person character. Of course, if you have another blueprint, choose that and make sure you don't get something else. Alright, and this is going to be an array because we want to store multiple characters inside the one variable. Okay, let me get once again the events. Okay, now the first thing that we are going to do with event begin play is that we want to make sure that the other actor is not equal to self. We do not want to count our player as an enemy. We cannot log on to our own self. If this is true, then we are going to cast to the third person character. This way we make sure that whatever we collided with is going to have the type of a third person character. If that is true, we are going to get our enemy array and then add, and in here we are going to add a third person character. So now we are going to have a reference to this blueprint, and from end overlap, once again, let's copy this. We first want to make sure that we are not stopping to collide with ourselves, because that is going to get weird. And then we want to make sure that whatever we ended the overlap with is going to be a third person character. And if that is true, let's get our enemy array and let's get a find node. The find node is going to try to find this third person character we ended the overlap with in our array. And if it didn't find anything, then the return value, the return integer here, is going to be -1. As you can see, the index the item was found at, or -1 if not found. So if this is not equal to -1, which means that we found an item, then we are going to remove this item from our enemy array. Remove item, and the item is going to be the cast. Okay, this should be enough for now. We're going to come back later and set up some things. But for now, let's get to something else. Now we want to see how we are going to log onto enemies. So let's go to Edit, Project Settings, Input, Action Mappings, and a new action mapping. I'm going to call this Log On Enemy. I'll bind it to my Q button. So let's call it in here, Log On Enemy. Okay, let's get a new boolean. I'm going to call this is locked. Because if we are already locked, we are not going to unlock the camera, but instead we are going to toggle between other enemies. But if we are not locked, which is by default false, so we first want to log onto an enemy, we are going to do the following. We are going to have enemy array, we'll get length, and we want to see if this is bigger or equal to 1. So if there are any enemies in this array, then we are going to see if we can log on any. Right, let's create a function, select enemy. We are not yet going to set it up, let's just create it for now and put this on true. Okay, let's create a new variable. I'm going to call this locked on enemy, and it's going to be again a third person character reference. This time it's going to be a single variable. So if the locked on enemy that is going to be selected after the select enemy is valid, so what we selected is valid, then we are going to get is locked and set it to be true. Then we are going to create a new custom event called rotate camera. Again, we are not going to set this up, not yet. I'm going to call here rotate camera. Then we are going to get our camera boom, and we are going to set use on control rotation to be false. Otherwise, this is not going to work, so make sure you do this. Okay, so for now, this is everything we need to do here. Still not going to set it up yet. Let's set up the true part as well. We're going to get the enemy array. We're going to get length once again. Okay, and now we are going to see if this is bigger or equal to 1. Okay, now I'm going to press B and put a branch down. So you can get this by pressing B and left click. Or of course, traditionally you can just type here branch and you're going to get it. And I'm going to get a switch on integer, because here we're going to have two cases of toggling or resetting the camera. Let's get again the length. So we already know that the length is bigger or equal to 1. Let's get the start index to be 1 and let's add some pins. Okay? So if the length is exactly equal to 1, we're going to create a new custom event, and I'm going to call this reset camera. So if this is exactly equal to 1, we're going to reset the camera. Okay, but if there are 2 or more enemies, so from both 2 and default, what we'll do is to get a select enemy and plug this in here and this in here. Okay, and then we're going to have another custom event, change enemy. Okay, and let me call this here as well. So call change enemy. Now let me explain what each function will do. So the rotate camera is simply going to make sure that the spring arm the camera boom is always going to face the enemy, so the follow camera is always going to look directly at the enemy. Then the reset camera, as you saw in the beginning, there are going to be some effects with the FOV and the arm length from the camera boom. By using reset camera, we are going to make sure that we reset those to default once we are not going to lock or target any enemies. Change enemy is going to make sure that after toggling from an enemy to the other, there's going to be a smooth transition and the camera rotation is not going to be set in one tick, which means very sudden teleportation. Okay, and now as I said, here we will need to continue a little bit of blueprint. So what we have to do is to make sure that the third person character that we stop the overlap event with is not equal to the locked on enemy. So if both of these are equal, what we'll do is to reset the camera. Call reset camera, compile, and that should be it. And now what we have to do is to set up these functions and custom events. I'm going to try to make this as less confusing as possible. So first let's start with reset camera, because this is going to work with a false part from our input action, so this makes kind of the most sense. Make sure that you have enough space because there's going to be kind of a lot of code as well. So let's start. First of all, what we want to make sure that we have on reset camera is that our lock on enemy is valid. So if this is valid, we will have to do the following: get locked on enemy, get decal, talking about the component, and then set visibility. And this should be false. And also this reminded me that we need to go to the decal and set visibility to false by default as well. We do not want to be able to see this by default. Right, then we are going to clear locked on enemy by setting this on a null set. Okay, then what we'll do is to get is locked, set this to false, then get the player controller, right, set control rotation, get the camera boom, get world rotation, and plug this in here. The reason we do this is because once we are going to reset the use pawn control rotation back to true, the control rotation is going to take over the camera boom, which means that there is going to be a sudden teleportation in the rotation, which will get a pretty ugly result once we'll stop locking onto a camera. So imagine the camera boom getting back to the initial rotation before locking on, although we rotated it a lot of degrees from that starting point. I'm going to show you later why exactly we need to do this and how it looks without this node. Okay, then let's get the camera boom again and set use pawn control rotation back to true. Okay, now what we need to do is to add here a timeline. I'm going to call this effects, and we are going to reverse this. Okay, and from use pawn control rotation false, we are going to play it. Let's get into it. Create a new float track. I'm going to call it lerp, time 0 value 0, another keyframe time 0.5 value 1, and the total length 0.5. Okay, and make sure that this is great. Right, now we are going to get an is node. In fact, we are going to get two. Both of them are going to have the function of expo in out and expo in out. Again, the alphas are going to be the lerp track. Okay, so the first one, I'm going to use this to set the target arm length for my camera boom. So set target arm length, update, plug this in here, and now you are going to have to choose your values. My default one is 250. I changed it, as you can see, with this arrow. So I think by default this is 300. So whatever is in here by default, you should put in A. And then your target, which for me is going to be 150. Okay, then for the other one, I want to set the FOV of the camera. Set field of view. Once again, plug the result of the is in the field of view, and now we can set the values. By default for me this is 90, so plug 90 in here, and my target is going to be 80. Okay, now this is everything we have to do for now with this timeline and the reset camera function. We'll need to work with the finished event as well, but not for now. That's going to come later. Now let's set the rotate camera function. Okay, now what we want to do here is to add another timeline. I'm going to call this rotate, and you can just have play. This is going to loop, and the length is going to be 1. The length really doesn't matter. Okay, now we want to see if our locked on enemy is valid. So maybe something else happened with him, so we don't want to rotate anymore. And if he is valid, then we are going to get the camera boom, or spring arm, however you want to call it, and set world rotation. Keep in mind, this is not going to work if you do not set the use spawn control rotation to be false from your false part on the input action. Make sure that is on false. Okay, and now for the rotation, what we'll do is to get a camera boom, get world location, okay, then get a locked on enemy, get world location, play into get actor location. Okay, and now we are going to use a very neat function called find look at rotation. And in fact, this is a macro, not a function. And by using this and by plugging this in new rotation, we'll make sure that we are always going to look towards an enemy. And if I'm going to go to my locked on enemy and I'm going to expose it, press compile, then go to this character of mine, then go to locked on enemy and pick one of these guys and press play. Perhaps I'm going to be able to show you what's going to happen. So apparently it doesn't work yet. So we'll need to go and see at the end what's going to happen. I'm going to de-expose my variable and let's continue now. And now almost the last thing that we have to set up is this change enemy. We'll need to make sure that we are close to rotate camera. Let's get a sequence, and from then on we are going to stop this timeline. And let's get a new variable. I'm going to call this initial rotation. It is going to be a rotator. Okay, and we are going to set it, and this one is going to be the rotation of the camera boom. Get world rotation, and we'll play this in here. Then we'll create a new timeline. We're going to call this lerp. Always play from start. Float track. Going to also call this lerp. And tunic key. Tunic is 1 times 0 value 0 and 1 times 0.5 value 1. Length 0.5, because this is as well basically a copy of this timeline. Okay, on update, what we'll do is to get an is function. Okay, this is going to be circular in out. The alpha is going to be the lerp. For A, we are going to have initial rotation. And then we can copy once again this and plug this in B. Alright, we are going to set world rotation. The result is going to be new rotation, and then on finished we are going to play once again this timeline. Okay, so this should be everything for this function as well. And now there's one problem. If it were for this to currently work, which now it might work, but we can't test it yet because there's going to be one error. So once we are going to lock onto an enemy, we are not going to use the control rotation anymore because we are not going to use the pawn control rotation. So instead of that, we will need to use the follow camera for our rotations. So here on get control rotation on movement input, we are going to have a select node. The index is going to be is locked. If this is false, so we are not locking on anything, we are going to use the default control rotation. But if we are locked, we'll get the follow camera, get world rotation, and if this is true, we are going to plug it in here. Now let's see if I'm able to have this exposed and use it. See, locked on enemy, I'm going to choose this one. I'm going to play, and now let's press the button for that being Q. You can see what happened. I'm now going to follow the enemy. I'm going to be able to follow him depending on what my camera rotation is. Okay, and now let's use only the default control rotation and see what's going to happen. Play and check one more time. If now I'm going to press W, I'm going to go forward. But as I'm going to continue to press W, I'm going to go in the same direction. I am not going to follow him. But instead, if we are going to use the camera world rotation, I'm going to press W, I'm going to go towards the enemy, which is exactly what we want, right? And then for left and right as well, I'm going to continue to rotate around him. Right, and that should be everything for that function. Well, I'm not yet able to test this as well because we need to have the select enemy, because right now we are using an artificial method of selecting the enemy in the editor. So let's reset that. Let's deexpose the variable, and now we have to go and set up select enemy. So first of all, let's create one new local variable. I'm going to call this last enemy. It's going to be a third person character. Alright, and let's set this to be the locked enemy. Okay, then we want to see if the locked enemy is valid. We can also do this in front of it. Why not? Okay, so if the locked enemy is valid, we set the last enemy. Okay, and now we are going to get a for each loop. The array is going to be the enemy array. Okay, and now we want to see if the array elements are valid. Again, is valid, because perhaps something happened in the meantime. Of course, we want to it won't really affect the performance if we use this function, so why not use it to make sure we don't get errors. Okay, let's get a line trace by channel. Line trace by channel. And this line trace is going to make sure that there are no obstacles between me and the enemy, because we do not want to be able to lock through walls to our enemies. The start is going to be get actor location, the target being self, and then get actor location for the array element. If the return value is false, then we are going to create a new variable for this one. I'm going to call this enemies underline distances. Name it as you want, it doesn't really matter. Let's choose float, and this one is going to be a map. The other type of variable is going to be third person character. Okay, so let's get enemies and distances and get an add node. The enemy is going to be the array element, and the float is going to be a get distance to. Target is going to be the array element, and the other actor is going to be self. Okay, so now we can store the distance between our character and the character itself, and the enemy itself, I mean. Okay, then from completed, let's have a branch here, and we want to see if we are locked already. If we are going to be locked, we are going to toggle it between enemies, but if we are not locked, we are going to lock on the closest one. So what we'll do is to get the enemies and distances, get keys, and then from this array, we are going to get a minimum of float array. Then from enemies and distances, we are going to have a find node, and we are going to find the enemy that has this distance. Okay, let's have here is valid once again, making sure that we are not going to get any errors. And if this is valid, then we are going to set the enemy. We're going to get a locked on enemy, set this to be the find result, and then also set get decal and set its visibility to true. Set visibility to be true. You can also collapse this into another function, set enemy, so it's easier for us because we're going to use this a couple of times. Okay, now we have to set a true part. Let's first create on these connections. Okay, now I'm going to get enemies and distances again. I'm going to get values, and then I'm going to get the enemy array, and I want to find an item. I want to find the locked on enemy. Alright. Actually, what we can do is that we can use the last enemy. Right? We want to find the last enemy, and then we want to add to this integer 1. Then from our enemy array, let's get a copy, and the integer, the index, is going to be this sum right here. And we want to see if this is valid. Okay, if this is valid, we are going to choose this as our next enemy. We're going to have a branch first, and we want to make sure that enemies and distances, this array for the values, contain this get. We want to make sure that in the beginning here we also got this enemy, because in the meantime maybe we moved and our sphere collision updated. So if the enemy that we found in this array with an +1 index from the last enemy is in the enemies and distances values, then what we are going to do is to set enemy. So the function set enemy, as I said, locked on enemy is going to be the get node. Okay, and then we are going to get last enemy. Okay, get decal and set visibility to be false. Set visibility to be false because we want to reset that circle around him. That means that it is locked. Okay, so false, make sure that it's false. Let's make some more space in here. And if this is not valid, what we are going to do is to get again from values contains, and instead this time we're not going to check with the last enemy, find an index in our array and see if that's valid or not. We are going to check for the first, for the index 0 from enemy array. If that is in our values from enemies and distances, right? So if that is true, once again, we copy this part. Okay, and plug the lock on enemy into the get. Okay, so let me explain this one more time because this might have been confusing. So what we'll do is to first get the values from enemies and distances. Then we are going to get the current index of our of the enemy that we are locked on, right? This is going to, we can still choose locked on enemy for now, so no need to use last enemy. So we are going to get the index of the locked on enemy. Then we are going to add 1 to that index, and we want to see if that index is valid in the enemy array. If it's not, then we are going to get the enemy that has the index 0, right? We make sure that this is valid as well, using contains, and then set it as our enemy, and the visibility of the decal from the last enemy to be false. Right, but if the item with the index +1 is valid, then we are going to set the enemy to be that one, right? The next index from the locked on enemy, right? And then set the visibility again of the last enemy to be false. Hopefully this made sense, but I just noticed that we are going to have some problems here. So first of all, here, this should not be true, this is my mistake, this should be false. And as well, we do not want to check if this is valid or not, because most of the time, and especially when you first start, this is not going to be valid because there's not going to be any value to hold for our variable. Of course, this should be everything for now, all the errors. What we need to do now from false is to reset the camera. Okay, so reset camera and reset camera. So if none of these are true, there's no reason to continue to lock on to something that doesn't exist. We'll simply reset the camera. So let's try. I'm going to press Q. You can see the circle that is fit that are going to that's going to appear. I'm going to press Q once again. You can see this transitioning to the other one. Pressing Q again to the last one, and then if I'm going to press Q one more time, this is going to start over, and so on as many times as I want. And this is going to be very smoothly done as well. Alright, and then if I'm going to get out of the bounds of my sphere, this is simply going to reset. Okay, if I'm going to press Q one more time with only one guy in my sphere, this is going to reset. Okay, but I need to make sure that there's only one. So as you can see, there's only one enemy in my sphere, and if I press Q one more time after focusing on it, it is going to get unfocused. Okay, but it seems that we are getting some errors at a certain set world. Okay, so the world rotation, here's a problem. So how I like to solve this, and this is actually the way to solve them, is to get locked on enemy, check if this is valid or not, and if it's valid, only then I want to do it. Because there are some parts in which my locked on enemy is going to be invalid while we are doing these transitions, but otherwise you can see it's still working just as fine. So there's nothing to worry about, we are not going to get those errors anymore. Okay, now one thing I want to explain is this set initial rotation. We could of course just use the get world rotation every time, but this would result into an error. I'm going to press Q and then I'm going to transition to the other one. This is going to look fine. But if I'm going to keep moving while doing this, you're going to see this problem. This is not something we want. And by saving this into a variable, that we are going to avoid that. Okay, and one last thing we have to do is setting up a sprint method. That might seem unnecessary, but that's going to be the way we are going to unlock our enemy. So let's go to project settings, go to input, action mappings, and get sprint. This is going to be bound to my left shift. Now let's get this sprint, get a new variable, is running, is sprinting, or however you want it, by default false, and on pressed true, and on released false. Then get a camera movement, character movement I mean, set max walk speed, when we want to run 800, okay, and when we are going to walk, back to the default value, that being for me 600. Of course you can play around with these values. Make sure that for the walking part you always get the same value as in the max walk speed here. Okay, and then let's go a little bit back to the movement input. So we can leave this aside, this is all we are going to work on now. Here, after whenever we add movement input, what we want to do is to check if we are both locked If we are both locked and running, then what we're going to do is to reset camera. Okay, make sure you plug this in the branch. So this is going to take 2 booleans or more if you add pins. If all of them are true, then the result is going to be true. If some of them are true, some of them are false, then it's going to return false. Let's play. Okay, by pressing shift I'm going to go faster. You might be able to notice it. Let's try with a bigger value. Let's try 8000 just for the memes. So you can see 8000 being very fast, and after releasing it, it's going to go smoothly. Take to 800, play, and I'm going to press Q to lock on. Now if I'm going to press shift and run, it is going to get unselected. If I'm only going to press shift, it's not going to do, actually it is going to do something. The only reason for that being is I'm going to get, this is going to fire even if I'm not pressing anything, but that's fine. You can do that as well, or perhaps you can get here float, bigger or equal than float. Okay, get axis value in the first one, and I'm going to put here 0.1, get myself some more space. I'm going to copy this as well, plug the second axis value, get an OR boolean. So if any of these, if this is true but this is false, the return is going to be true. If both are false, the return is going to be false, but if both are true, the return is going to be true. A new pin, plug this in here, and now this should work. I'm going to lock on, press shift, and you can see it not happening, but if I'm going to move, it is going to go just fine, right? So, as you can see, right, pressing shift, and it's going to work. But of course, you don't have to do this as well. That's pretty much everything we have to do in our blueprints. And that's it for today's UE4 tutorial. Thanks a lot for watching this video. I hope it was helpful and informative. Let me know down below if you have any other questions regarding the tutorial, and I'll make sure to answer them. For Patreons, the project files from this tutorial will be available over on my Patreon page. Once again, thanks a lot for watching, and I'll catch you in the next one.